take the derivative of f of x multiplied by g of x, and you may know this as a product rule, which would equal to f of x multiplied by g prime of x plus f prime of x multiplied by g of x. Now let's take the integral from both parts, quantity here, dx, and integral from this part, dx. The derivative and antiderivative will cancel. It's the fundamental theorem of calculus, and you should know it. F of x multiplied by g of x is something that we're left with, and there's going to be an integral of f of x multiplied by g prime of x dx plus integral of f prime of x multiplied by g of x dx. Now, let's subtract this part of our equation from both parts. We would have f of x multiplied by g of x minus this part, integral of f prime of x multiplied by g of x dx equals to this part, the one we're left with, integral of f of x g prime of x dx. Let's make a substitution. Or we'll say that let u be equal to f of x. Now, we know the derivative of u would be du, and derivative of x of f of x would be f prime of x dx. Let's go here and substitute. Instead of f of x, we're going to have u multiplied by g of x minus integral of f prime of x dx would be just du. So let's say g of x multiplied by du equals to f of x is u multiplied by g prime of x dx. Let's substitute the next value. Let v be equal to g of x and dv be equal to g prime of x dx, since that's a derivative of g of x. And now we can substitute further and say that instead of gx, we're going to have v minus integral of, instead of gx, we have just v du equals the integral of u, and g prime of x dx is simply dv. Let's rewrite it as u dv equals to uv minus integral of v du. And this is the proof of the integration by parts. Thank you.